So now we want to look at arranging things in a definite order with no repetitions. These are called permutations. We're not necessarily taking all of our objects as we were before, but we're taking some of the objects. These are going to be considered those permutations because we're going to place them in a certain order. In a set of n elements, so this is our total number of things we have to select from, the number of ways we can choose r elements, this is how many we're selecting, from the set in order, the permutations of n objects taken r at a time is given by this formula. NPR is equal to n factorial divided by n minus r factorial. So we're going to divide by the n minus r. Now, n always has to be larger than r. So the first number always is larger than your r. So how many ways can a president, vice president, secretary, and treasurer be chosen from 10 committee members? Now you know this is going to be a permutation because you have positions. If it just said 4 committee members selected, then this wouldn't be a permutation. But since it gives us positions, this is going to be a permutation. So we're selecting 4 from our 10. So this is our n, and this is our r. So we have 10 PR, 10 P4. So we're going to have 10 factorial divided by a 10 minus 4 factorial. So that's going to be 10 factorial divided by a 6 factorial. And one of the things that you can think of here is 10 factorial is 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. 6 factorial is 6, 5, 4, 3, 2, and 1. Or 6 factorial. These are all going to cancel out with these, right? Because you can simplify them 1 for 1. So actually, all I end up getting, if you look at these two numbers, take the difference, whatever number this is, start with the number just above it, 7, and go from this number to the number just before, 10, 9, 8, and 7. Multiply those, and you will get that there are 5,040 different ways that you can select 4 members to become those 4 positions from 10. Now here, we want to select 5 different letter words that can be formed from the letters of decagon. Now decagon has 7 letters. So we have 7 letters that we're going to select from, and we're going to select 5 letter words. So this is 7 factorial over 7 minus 5 factorial. And so we have 7 factorial divided by 2 factorial. Well, this one's going to be 7, 6, 5, 4, 3, 2, and 1. This is just 2 and 1. So these things cancel out, leaving me with 7, 6, 5, 4, and 3. When I multiply those things together, I get 2,520 different ways that I can multiply, or different 5-letter words that I can get from decagon.